All right. So, hello and welcome everyone. I hope I'm audible to all of you. So, welcome back to this particular channel of Pradhan Academy. So, again, we are live again with today's topic, and today our topic is going to be definite integral, right? So, please let me know if you are able to hear me out. So, welcome back. And if you're new to this particular channel, then I would like to tell you that we have been basically discussing about the JEE Mains topics and especially the JEE Mains previous year questions. And each of the session we are coming live and we are discussing the important previous year questions from the each and every topic, right? So before you start with the topic, I would ask you or request you to all of you to please have a recap on this particular topic before you are watching this particular session live with me. Okay, and if you have covered the syllabus and you are done with your preparation, then I would request all of you to please stay with the session till the end, right? This session is going to be really important and useful for all the students who are basically preparing for the second attempt, right? Because in every day I'm coming live and we are discussing the topics. We are also doing a fast revision as well as we are basically solving the question and trying to understand the underlying concept behind the topics, right? So with this particular part, let's get started on this today's topic. And today our topic is basically definite integral. So today our topic is definite integral, right? So today we will be solving up the questions from definite integral. Now I know the definite integral is little bit of tricky chapter because it involves some of the properties, some of the important properties. And once you know the properties and once you know the way to handle and tackle those properties, you are going to ace the chapter very easily. All right. So I hope this is clear to every one of you. Okay. And if you're in this particular channel, you can find up all the JEE main session that I have taken so far on the channel. If you go to the channel and check out the live tab, you will find up all the contents that has been taken so far, right? So I would request all of you to please have a look through all those contents and try to go through and watch those particular lectures before you are coming from this. Okay, because those lectures are really important along with this particular session that are taking up now, right? So we are almost at the like a midway of the syllabus. So after definite integral, we are going to start with area under the curves, and then we move to the differential equation. Then that will mark the end of the calculus portion, right? And with that, I'm going to start with the vectors and 3D geometry, which is one of the most easiest and high scoring chapter, especially for your JEE mains and advanced examination. Okay. So with this particular note, before I start the session, I would like to tell you that before you start this particular sessions, you should always have a revision of your NCRT and you have solved the NCRT examples and as well as the solved examples, also the practice exercise. Okay, and after you're done with that, you have to basically solve the NCRT exemplar. You have to basically solve the NCRT exemplar, right? So if you are done solving this two particular part, and if you have made short notes, and if you have made short notes, then this session is going to be really useful for all of you. Okay, so once you're done with this particular job, then you can start watching this particular previous year question session. Okay, I hope this is clear to all of you. I hope this particular part is clear to all of you. All right, please let me know this part is clear or not. So, let's start our today's discussion on definite integral. So we will basically discuss about the important concepts of definite integral. We will also try to practice. We'll take up the previous year question of JEE Mains. We'll practice both MCQ and numerical type. We'll try to understand the concepts or how the questions are basically asked in JEE Advanced. And also with that, we'll try to predict the pattern of the paper that you can expect for this year. All right, for this attempt. All right. So let's get started on this particular work. So if you look at the weightage of this particular chapter, now I would like to tell you that this particular chapter has a really high weightage. Okay. If you look at 2024 data, the weightage of this particular chapter was around 2 to 3 questions. Okay. And in 2023, this chapter had 3 to 4 questions. And similarly, in 2022, this chapter again has high weightage, that is 2 to 3 questions. And similarly, in 2021, the pattern is very similar. The question was again like 3 to 4 questions. Okay. So with this part, you can understand that how important and how interesting and how fundamental this chapter is, right? So in everywhere you can find out the questions of definite integral used up, right? Even it's a basically like an applications of a integral, right? So once you understand definite integral, will apply the same thing, same concept to the questions of area under the curve. I hope this is clear to every one of you, right? So with this part, let's get started on the very first question. So very first question is on your screen over here. All right. So I would request all of you to please proceed to the question, try to have it a look and try to think how we are going to approach this particular problem. Right. So if you look at this problem is like a concept of a variable definite integral, right? The limits are variable. So if you look at the question over here, the question mentions about a function f of x which is defined from 0 to x, and it is defined as t into t square minus 90 plus 20 dt, right? And it is mentioned that when x is basically lying between 1 and 5, when x is basically lying between 1 and 5, right? Now, if we have this particular functional expression over here, which is basically a variable definite integral, right? Variable limit indefinite integral, right? Now, if we have to find out for the range of this particular integral, it is equivalent to solving this question for getting the maxima and getting the minima, right? So if you need to find out the maxima or the minima, we need to differentiate this particular function once, right? So let us try to first of all differentiate this particular function with respect to x for the first time, right? Or the first derivative of this function. So if we try to find out the first derivative of this function, now I can use the Newton-Leibniz rule. So by Newton-Leibniz rule, the differentiation of this particular variable integral can be given out as x into x squared minus 9x plus 20 into 1 minus 0, right? So therefore, you will see that this particular expression, that the first derivative of f of x is going to be x into x minus 4 into x minus 5, right? That is the given expression over here. Now, if you see, if you try to plot those critical points where f dash of x is 0, those points are basically 0, 4, and 5. And if you try to plot the sign scheme of first derivative of f of x, then the scheme is like plus and minus, right? So from here, what you can understand that at 0 it is a local minima, and similarly at 5 it is again a local minima, and at 4 it is maxima, right? So these two are local minima and one global local maxima, right? So if you try to find out now, since our interval of x is between 1 to 5, so this 0 does not count in, right? So 0 doesn't count in. So your x will basically be like is basically in between 1 to 5. So therefore, your range is basically f of 5. F of 5 will give you. So let us try to find out what is the value at f of 5, right? So if you try to find out the value at f of 5, and you can simply integrate this, so this value is going to come out as, so let us first of all find out f of 1, okay? Because there is a starting point. So let us first of all find out the f of 1. So that f of 1, so f of 1 we will have it as, now before we proceed with this, because once you have this particular expression, you can always try to integrate it back, right? You can always try to get it integrate back. And if we try to integrate with the variable integral over here, that is, if you try to find out what is f of x by integrating this is going to be x to the power 4 by 4 plus minus 9x cube by 3 plus 20x square by 2 plus 20x square by 2, right? So that is going to be the functional expression over here, right? Now, once you have this, let us try to put the values back into this equation and let us find out what is f of 1. So f of 1 is going to be equal to 29 by 4. Similarly, your f of 4 is going to be equal to 256 by 4 minus 3 into 64 and plus 10 times of 16, and that is going to be equal to 32. That is going to be equal to 32. Now if you find out f of 5, that is basically greater than 29 by 4, so therefore the minima is 29 by 4 and maxima is 32. Maxima is 32. So therefore your alpha is equal to 29 by 4 and your beta is basically 32. So therefore, if you now add alpha plus beta and multiply it with 4, this particular value is going to come out as, so if you just do the simplification, that is alpha plus beta into 32, sorry, into 4, this value is going to come out as 157, right? So this value is going to come out as 157. So with this, you will have option number B as the correct answer of this particular problem. Okay. So I hope this part is clear to all of you, right? We just simply apply the Newton-Leibniz rule to get out the maximum minima point, and then from there we basically find the range of the function, right? So it's a simple question which involves your integration, but it was not a question exactly of integration, right? So once you understand how to solve this question, these questions are very simple. It's just a question of applications of derivative, right? Okay, so Is this clear to every one of you? Is this clear to every one of you? Please let me know this particular part is clear or not, right? All right. So, okay. So I wish this is clear to all of you. So if this part is clear, let's proceed with the next problem. So let's proceed with the next problem. So the next problem is on our screen, right? So I would request all of you to please have it a look. And this is a very standard question. Okay. If you look at the NCERT textbook also, you will find this kinds of questions are present there in the NCERT as well, right? So you can understand that directly the question came up just from the NCERT, right? Just from your NCERT. So the question is talking about that we have an integral. So let us call this particular integral as integral 0 to pi by 4, and the integral is given as sine theta plus cos theta whole divided by 9 plus 16 times of sine 2 theta, right? And d theta. Okay. Now what I'm going to do over here is that I'm going to write this expression as sine theta plus cos theta, and whenever you see sine 2 theta, it is very understood that you can write this as 2 times of sine theta cos theta. And if you have 2 times of sine theta cos theta and 9 times of 1 is basically means sine square theta plus cos square theta. So therefore, you can try to write this entire expression of sine 2 theta in terms of sine theta plus or minus cos theta whole square. Right. So our try will try to understand and try to represent this denominator in terms of sine theta plus or minus cos theta whole square of that. Right. So if I do the same expression over here, I'm going to get it as, so this particular part is going to be 6 plus 16 times of 2 multiplied with sine theta cos theta, and therefore I can do this integration as, and therefore this I can write it as simply as, so if I just try to do it, so what I can see over here is that 16 times of sine theta cos theta and multiplied 2 is present, right? So and 9 is present over here, right? 9 is present over here. So what is the best way to do is that, so what I can do simply as, I can write this expression as 9 plus 16 minus 16 times of sine theta minus cos theta whole square. Now, if you try to evaluate this expression, you are going to get this exactly the same thing that is written in the denominator. Exactly the same thing that is written in the denominator, right? So that is what the integration simplifies out to, right? Now, it's very simple. Now, it is just a matter of fact of understanding that this is basically sine theta plus cos theta d theta, right? Divided by 25 minus 16 sine theta minus cos theta whole square, right? Now, interestingly, if you solve this question by substitution, that is, if you substitute sine theta minus cos theta as some t, then minus times of sine theta plus of cos theta d theta is going to be equal to dt, right? So therefore, this particular part is going to be minus of dt, is going to be minus of dt, right? I hope this is clear to every one of you. Now, once we have this particular expression, so we can try to represent this particular format as, so the integral will now change to dt divided by 25 minus 16t square, 25 minus 16t square, right? And if you have to change the limits of the integral, that is basically going from -1 to 0. Now we have minus sign over here, and if we simply apply the properties, I can replace this sign, okay? But it's okay, you can choose not to do it also. I have no issue. Then your integral is going to come out as, your integral is simply, now what you can do, you can make 16 common. So this 1 by 16 as common, and integral -1 to 0, -1 to 0, -1 to 0 dt upon, now this is going to be 5 upon 4, 5 upon 4 whole square minus t square, 5 upon 4 whole square minus t square. And now we know the formula for integration of dx upon x square minus a square, sorry, a square minus x square is basically equal to, this particular part is going to be equal to 1 upon 16. Now 1 by a will come out over here. So the formula is 1 by a log of 1 by 2a, sorry, 1 by 2 times of a into natural log of a minus x, sorry, a plus x divided by a minus x, right? And we put the limit, that is minus 1 to 0, and ultimately we have to report the answer of 80 times of I. So therefore, if you simplify this part out, so you are going to get this result as 1 upon, sorry, 2 times of natural log of, and then we put the values, right? And if you put them value and simplify, this is going to come out as, 4 times of natural log of 3, 4 times of natural log of 3. All right. So this is going to be the correct answer to this particular problem. So therefore, you can see from here, the answer to this question is going to be option number B, which is 4 natural log 3. So therefore, this question is very simple. And if you look at the NCERT textbook, you can definitely find this question there as in the solved examples. Okay. In the definite integral, in the chapter of integral, if you go to the part of definite integral, in the examples, you can definitely find this question in the NCERT textbook as well. All right. So I hope this is clear to every one of you. I hope this particular part is clear to every one of you, right? Please let me know that. All right, please let me know. I'm going through a live chat. All right. So if this part is clear to every one of you, we shall proceed with the next problem. Now we can proceed with the next problem. I hope this is making sense to all of you. If you have any question, you can let me know. Okay. All right. So I'm assuming you don't have any question. So let's proceed with the next problem then. So the next problem is on your screen. So if you look at this problem, it is said that there is a function small f which is going from real part to real part and is a twice differentiable function such that the functional value of small x or small f at 2 is equals to 1. And it is said the capital X, capital F of x is given as x times of small f of x, right? And it is defined for all x, belongs to real number, for all x belongs to real number. Now it is said that, the integral from 0 to 2, the integral from 0 to 2 x into f dash of x dx is equals to 6, and the integral 0 to 2 x square capital F double dash of x dx is going to be equal to 40, right? So we have these two given equations, and from these two given equation we have to find out the value for f dash of 2 plus integration of 0 to 2 of capital F of x dx, right? So I hope this is clear to every one of you. The question is simple and clear. So please, if this is part is clear, please try to solve this problem. Please try to go through this problem and try to solve it. Okay. The problem is very, very simple. Just give it a try. Okay. So first of and foremost thing, let us try to find out the f dash of capital F dash of x. So it is going to be equal to x into f dash of x plus small f of x, right? Now, now your value, now if you just put it in over in the first equation, the integral 0 to 2, x into small f of dash of x plus capital F dash of x, right? And dx over here, and this value is equal to 6, right? Now from this particular part, and if you put that in the second expression, let us try to differentiate it again. So if you put in the second expression, it is going to be f into small f double dash of x plus f dash of x plus f dash of x, right? So that is going to be equal to 2 times of f dash of x, right? Now once we have this expression, let us try to put that in the second expression, that is 0 to integral x square into x into small f dash of x plus 2 times of f dash of x dx is equals to 40. Now we have two equations and we have to solve for them, right? Because we are having no clue on what is a small f of x, right? So if we are having no idea on what is small f of x, what I'm going to do is that if you simply, now if you don't actually try to apply this particular format over here, if you just look at this particular expression, If we look at this particular expression, this is the expression of what we can think over here from this expression is that we try to apply the by parts over here. We try to apply the by parts over here. And if we look at applying by parts over here, an interesting thing will occur. An interesting thing will occur that you will try to see. So if you put the by parts, so I am solving by parts. So that is going to be equal to x into f of x and the integral 0 to 2 minus integration of 0 to 2 f dash of x, that is going to be equal to small f of x, right, dx. I hope this part is clear, and is equal to 6, and is equal to 6, right? All right. I hope this is clear, right? So what are we doing is that first of all, we are taking this small f of x, small f dash, sorry, capital F dash of x as the second function, and this is the first function, right? So if we do this simplification, you are going to get this result. Okay. I hope this is clear to every one of you. All right. So fine. So now we just proceed together. So now if we put the value back in this equation, just a second, did I do any mistake? I think this should be, yeah, capital F dash of x, right? Capital F of x, because, right, capital F of x, right? So I think this is clear. And now if we put the value of, now if we put the value of the given values, now if you put the values, the limits, and then solve for it, we are going to get it as, we are going to get it over here as that this particular value, we are going to get this particular value, right? That is integration of 0 to 2 capital F of x dx is going to come out as, 6, um sorry, if we take this on this side, and this is going to be minus of 6 plus 2 times of capital F of 2, 2 times of capital F of 2, and that is going to be equal to, minus of 2, because 2 times of capital F of 2 is basically putting this value x equals to 2 over here, and that is going to be 1 into 2, that is 2, right? So 2 into 2 is going to be 4, so 6 minus 6 plus 4 is going to be minus 2, right? So once we got this value, now our next turn is basically to find out, the second expression. So if we look at the second expression, again we do the by parts, is equal to 40. All right, now again we apply by parts, right? So this expression is going to be x squared into f dash of x from 0 to 2 minus integration 0 to 2, and it is going to be 2 times of x into f dash of x dx, right? Now again we have to apply by parts over here. But first of all, let us try to evaluate this expression. So this expression is going to be 4 times of f dash of 2, 4 times of f dash of 2 minus, and this particular expression, that is x into, there is 2 times of x into f dash of x. X into f dash of x is basically already given in the question, and that is basically given as 6. So this particular part is going to be minus 2 into 6, and this is given as equal to 40. So from here you get the value of f dash of 2. From here you get the value of f dash of 2 as equal to 13. So from here you get the value of f dash of 2 as equals to 13, right? And once you get a f dash of 2, so therefore f dash of 2 plus integral 0 to 2 capital F of x dx, therefore this result is going to come out as 13 minus of 2, and that is going to be 11. So from here you will get the solution to the question over here as option number B. So answer to this question is 11, that is option number B, as mentioned in the problem, right? So I hope this particular problem is simple and clear enough. So you just need to apply your open and clear mindset, right? So if you just do the problem by part, the problem is very, very simple, right? Rather we put in the value after differentiating it, and then we apply the by part, it's going to take a little bit more time. So instead, if you just try to apply the by parts in the initial expression itself, then the problem statement is much simple, right? So once you do this expression, you will understand how to decompose the given integral into the two forms over here, right? I hope this particular part is clear to all of you. Please let me know this particular part is clear or not. Is this part clear to every one of you? All right. I'm assuming this particular part is clear to every one of you, right? Please let me know if you have any questions. Please let me know if if you have any questions. Okay. And if you're watching the session after the live class is over, you can always comment your questions in the comment section. Okay. I'll be very happy to answer your questions. All right. But please don't make this particular mistake of not asking your doubts. Okay. Ask your doubts, get your doubts cleared. Okay. Because if you are clear with the doubts, if you are clear with the concepts, then it is very simple and you can basically do the examination quite easily, right? Because if you have any slight doubt, then when the same question comes up in the examination, you will have a lot of difficulty to tackle that problem in the examination, right? So in order to avoid the situation, it is always advisable to ask your doubt, okay, rather than having a wrong intuition or wrong concept in your mind. So with this, let's move to the next problem. So the next problem is again a very interesting problem. If you look at this problem, this question is talking about that f be a real valued continuous function which is defined on the positive real axis, such that your g of x is basically integral 0 to x t f of t dt, right? So once we have this expression over here, it is said that your function value of g of x is going to be integral 0 to x t into f of t dt, right? So it's a kind question of again variable definite integral. As you can see, the limits of the definite integral is variable, that is going till x, right? So once we have this expression, and it is said that g of x cube is basically equal to x to the power 6 plus x to the power 7 over here. Now, if we have this expression and it is said that f is a real valued continuous function, so we can first of all try to think of applying the question by using the Newton-Leibniz rule. Let us try to first of all differentiate the function and let us try to understand the nature of the function. So let us try to do this in the following format. So if I try to find out the g dash of x, the result is going to be x into f of x into 1 minus of 0, right? So it is going to be equal to f x into f of x, that is your g dash of x is going to be equal to x into f of x, right? X into f of x. And again, if you look at this problem over here, now in place of x cube, you put x. If you change x cube as x, this is going to be x squared plus this is going to be 7 by 3. This is going to be x to the power 7 by 3. And now if I apply g dash of x over here, this is going to be 2 times of x plus 7 by 3 times of x to the power 4 by 3, right? And this is basically equal to this particular expression over here, right? Now, now from this particular expression, what we find out that f of x is equals to g dash of x by x. Now, ultimately, if you look at the problem, we have to find out the summation of f of r cube. So therefore, your f of r cube is going to be equal to g dash of x cube or r cube, sorry. So g dash of r cube divided by r over here, right? And once we have this expression, this is basically equal to 2 times of r plus, sorry, it's going to be 2 times of r plus 7 by 3 r to the power 4 by 3 whole divided by r, right? Now, now if you divide by r over here, this particular expression is going to be simply equal to 2 plus 7 by 3 r over here, right? Now we have to basically find the summation of r going from 1 to 15, r going to from 1 to 15 f of r cube, and that is going to be equal to 2 plus 7 by 3 times of r, right? And if you apply the summation over here for r goes to 1 to 15, this value is equals to 2 into 15 plus 7 by 3 times of 15 into 16 divided by 2. And if you simplify this expression is going to come out as 310. This expression is going to come out as 310. So from here you can see the answer to this particular problem is going to be option number C over here. So this question is again a mismatch question. So once you understand how to find the derivative, because if you try to find the derivative, the question is much simple. The question is much simple. Okay. Is this part clear to all of you? Is this part clear to all of you? Please let me know if you have any questions. If you have any question, please let me know. All right. I'm expecting this question is clear and simple for all of you. Are you all getting the answer as option number C? Are you all getting the answer as option number C? Please let me know. Okay. So this is very simple and clear to every one of you, right? So the question is given in terms of an unknown function, and that unknown function is given in another terms of a function, which is given expression, right? So once we have this particular expression, we find out the derivative, and from that we basically get the value of f of x, right? F of x is simply equal to g dash of x by x, right? So once you know this particular expression comes out very simple, then the solution to the problem is much simple. It's just finding out the summation of the f of r cube. I hope this is clear to all of you. Please let me know this particular part is clear or not. All right. So if this part is clear, let's move to the next problem. So next problem is again a very interesting problem. And in this problem, I'm going to tell you the importance of using the properties of definite integrals, right? So if you recall the properties of definite integrals, so the most important property, that's what we call as a King's property, right? That is whenever your integral is from so let us tell your integral is from a to b, your integral is from a to b f of x dx, then the result is basically a is equals to, can also be written as integral from a to b f of a plus b minus x dx. Okay. Now if this, so this is basically one of the most important property, right? So if you are done with the chapter, you must know about this property, right? So once we know this particular property, what I'm going to do over here is that I'm going to simply use a property over here. So I can write the integral I. So let us call this integral I, that is minus pi by 2 to plus of pi by 2, 96 x square into cos square x divided by 1 plus e to the power x dx. Right. Now, if I apply this King's property, I can write this expression as minus pi by 2 to pi by 2, but in place of x, it will be replaced by a plus b minus x. So that is going to be equal to minus of x, right? So that is going to be 96 x square into cos square x, because x square is an even function, cos square is an even function, but the only effect is going to be e to the power minus x, right? And dx. Now, if we have this as the integral expression I and I, so let us consider the first equation and let us consider the second equation. So if I add 1 plus 2, I'm going to get this expression as 2 times of I is basically integral minus pi by 2 to pi by 2, and this is going to be equal to 96 x square cos square x is going to be common into, and that is basically coming out as e to the power x plus 1 divided by e to the power x plus 1, and that expression is going to cancel out, and ultimately the integral is going to simplify in terms of 96 x square, 96 times of x square into cos square x. Now we are going to simplify this expression out as, so 2 times of integral is going to be 96 times of integral going from minus pi by 2 to pi by 2. Now again you can simplify this limit also, that is totally your wish. So this is going to be 48 times over here, and again since this function is an even function, so you can always try to replace this integral in terms of 0 to pi by 2, right? And that will be 2 times of 0 to pi by 2, that's it. So you can do that also. So and then I can write this cos square x as 1 plus cos 2x, 1 plus cos 2x by 2. Okay, so I can write this as 1 plus cos 2x over here dx, right? Now once we know this expression can be simplified as, this is basically equal to integral is equal to 48 times of, now this first expression is going to be x cube by 3. So this by 2 term over here is getting cancelled out by changing out this integral in format of 0 to pi by 2, right? 2 times of 0 to pi by 2, and that 2 and this particular 2 is getting cancelled out. So I have some step jump over here, right? So it is going to be x cube by 3, and the integral is from 0 to pi by 2 plus integral from 0 to pi by 2 x squared into cos of 2x dx, right? Now again, I'm going to apply a simple property over here. So if you look at the solution, it is given in terms of pi times of alpha pi cube plus beta, right? So if again I have to apply the simple expression of the by parts. So if I just try to simplify the by parts over here, I'll try to get the solution of the result, right? So I can leave that solution up to you, and please try to get this particular by parts. Okay, please try to get this solution by parts, and ultimately the answer you will get it as pi times of 12 pi square minus of 12, pi times of 12 pi square minus 12. So ultimately the value of alpha is equal to 2 and value of beta is equal to minus of 12, and the value of beta is equals to minus of 12. So therefore alpha plus beta whole square alpha plus beta whole square is going to be equal to 100. Alpha plus beta whole square is going to be equal to 100. I hope this is simple and clear to all of you, right? So with this, option number B is going to be the correct answer to this particular problem, right? Is this clear to all of you? Is this part clear to all of you? Is this part clear to all of you? So once you do this by parts expression, I am leaving that part up to you. So please try to solve the by parts. Okay, this will be little bit like a matter of patience. Okay, you have to have some patience and to solve it. So once you apply the by parts over here, you are going to get the result very simple. Okay, so the solution to the question is going to be 100, and that is option number B over here, right? Are you all getting option number B? Are you all getting option number B as the correct answer? Please let me know, are you all getting option number B? Okay, so I'm leaving the by parts calculation up to you, and solve it and let me know. All right, I hope this part is clear to all of you, right? All right, so it is clear. Let's proceed with the next problem then. So let's proceed with the next problem. So the next problem is on our screen, and this problem is a format of something called as a beta function. This is called as a beta function. Okay, now when you go to your university, you will understand about beta function. Okay, this particular function is defined as a beta function, right? And the solution of this particular integral is going to be gamma of m into gamma of n divided by gamma of m plus n, right? That is going to be a solution, right? So I hope you don't know about the gamma function. So this is basically useless in terms of this question. So let us try to understand how we can proceed with this question, right? So it is said that I of m comma n is basically going from integral 0 to 1, x to the power m minus 1 into 1 minus x to the power n minus 1. Now interestingly, if you apply the King's property over here, that is the property that I was discussing about. So if you apply the King's property again over here, now before we apply the King's property, another very interesting thing is that now you know that sine square theta and cos square theta are related by just 1, right? Because sine square theta plus cos square theta is equal to 1. So what I'm going to do is over here is that I'm going to put x as sine square theta. And if I put x as sine square theta, our dx is going to be equal to 2 times of sine theta cos theta d theta, right? And if you do this simplification, then your I is going to be 0 to pi by 2, 0 to pi by 2. This is going to be sine of sine square m minus 1 into x plus, oh sorry, I put it in theta, so theta plus, sorry, not plus, multiplied, so multiplied with, and 1 minus sine square theta is going to be cos square theta, and that is going to be equal to cos theta of whole to the power 2n minus 1, and ultimately d theta, and then multiply with the sine 2 theta, right? We have a sine 2 theta over here. Is this clear? Now if we try to put the value of 9 comma 14 as m and n, the value is going to be equal to, the value is integral of 2 times of 0 to pi by 2. Now I just club this sine 2 theta as sine theta and cos theta and multiplied with each of the individual properties, so that is going to be equal to, and if we put the value of m is equal to 9, the result is going to be equal to, so it is basically n minus 1 multiplied with 2, right? Okay, now this result is going to be equal to 17, and this is basically equal to cos theta to the power cos theta to the power 27 d theta. Okay, cos theta to the power 27 d theta, and the value of I times of 10 comma 13 is going to be equal to 2 times of integral 0 to pi by 2 0 to pi by 2 cos to the power 17, sorry, cos to the power 19, sorry, sin to the power 19, and cos to the power 25 d theta, right? And we have to basically find the expression of I 19 comma 14 plus I times of 10 comma 13, and that is basically 2 common, and we basically apply the simple property, that is 0 to pi by 2, and we take club it. So therefore if I take sin to the power 17 theta and cos to the power 25 theta as common, then the result is going to be sin square theta plus cos square theta over here d theta, and this is going to be equal to 1. So ultimately this particular expression is going to simplify as I times of 9 comma 13, I times of 9 comma 13, right? I hope this is clear. So therefore, the integral expression, we don't need to solve for the integral expression. If we just apply this particular simplification, then the question is very, very simple. We have to represent the I 19 comma 14 plus I 10 comma 13 in terms of I some m comma n, right? So therefore, ultimately, the solution of this question is going to be option number D over here. Is this clear to all of you? Now, this is a very, very interesting problem. You don't need to actually solve for this problem. We have to basically try to express the given expression or the given question in terms of the other problem. All right. Is this clear to all of you? Is this part clear to all of you? Let me know if this part is clear or not. Okay, very interesting problem. Okay, very interesting problem, and please make sure that you remember this particular part of solution on this problem. Okay, because this problem is really, really important, especially for your JEE mains. Okay, and if you look at the JEE main previous year question, this type of problems has been repeated with little bit of mix and match. Okay, this type of problems has been repeated with a mix and match. Okay, so I am assuming this is clear to all of you. So this sin 2 theta over here, I hope this is visible now. All right. Okay, fine. So it is clear to all of you. I would have some homework problem for all of you. Okay. So this is the first homework problem that I would like all of you to solve for it. Okay. So please try to solve for this homework problem. This is a homework problem number 1. This is a homework problem number 1. Please take a screenshot. Please take a screenshot. Also, you can join the Telegram channel to get access to these lecture materials. Okay. Please take a screenshot. This is the first homework problem, and let me know the answers you are getting in the comments. Okay. Answers in the comments. Okay. And then we have one more homework problem. And this is the second homework problem. This is your second homework problem. Okay. Again, it is a very simple problem where we again have to simplify the parts. Okay. So what you can do is that you can assume this log x as some variable t. And if you do that, you will see that 1 by x into dx is going to be simply equal to dt. 1 by x dx is going to be simply equal to dt. So try to solve this problem. This is a very simple problem. If you just simplify this part out, you will going to get the correct answer to this particular problem. Okay. So let us keep this problem as homework problem, and please let me know the answers in the comment section. Okay. And if you want any lecture materials, any personalized content, and let any personalized one-to-one doubt clearance, you can always contact the number given in the description box. Okay. So with this, I hope you can understand the sessions very well. Okay. The session was clear and amazing for all of you, right? And if you like this particular video, then don't forget to hit the like button, and also you can share this video among your friends so that your friends can also join for the sessions. Okay. And don't forget to hit the subscribe button as well as click on the bell icon so don't miss out any upcoming notification for this particular contents. Okay. We are basically coming live daily, and we are discussing every day some of the important topics of maths, and in this topics we are discussing the previous year question especially, and we are trying to predict what are the special types of questions that can be coming up in the upcoming JEE mains. All right. So with this note, let's end our session over here, and thank you.